A supposed comet is catching the attention of some of the nation's most renowned scientists.
Right now, an interstellar visitor, 3I-ATLAS, is on a path that has scientists reeling. Its strange pulsing tail and sudden shifts in speed are forcing experts to rethink every assumption about these wanderers from deep space.
It doesn't look like a very common thing, and we've never seen such a thing.
For months, it was a distant curiosity, but the latest observations reveal a shocking truth. Its course is veering dramatically. This object, much like a ghost in the cosmic machine, seems to possess an unpredictable will, shattering previous calculations. We are on the precipice of witnessing an event that could change our understanding of what lies beyond our solar system forever. A collision course confirmed. The comet's trajectory is no longer a gentle curve. It's tightening, drawing ever closer to the red planet. Its speed is shifting not in the predictable dance of gravity and inertia, but with an unnerving, almost deliberate alteration. For the very first time in our scientific history, the numbers suggest a possible direct impact with Mars. At nearly 87 kilometers per second, or about 194,000 miles per hour, 3I-ATLAS is moving faster than anything humanity has ever tracked across such a vast distance. To put that in perspective, a jet airliner travels at roughly 600 miles per hour. This object is moving over 300 times faster. The sheer velocity is a wow factor in itself, making any evasive action for Mars or its orbiting spacecraft nearly impossible. But not all things are what they seem, and 3I-ATLAS is proving this cosmic truth in the most perplexing ways. Its tail, a shimmering plume of gas and dust that should behave like any other comets, is doing something extraordinary. It pulses. Every 17 minutes, with clockwork precision, it releases bursts of gas. Many people are crazy about trying to understand why this is happening. This isn't the chaotic outgassing of a typical icy body. This is a rhythmic, almost mechanical operation. It's as if the object itself is adjusting its course. Subtle corrections that defy our understanding of natural cometary mechanics. Think of it like a rudder on a ship, guiding its path through the cosmic ocean, except this ship is traveling at unthinkable speeds. What makes this even more unsettling are the observations made through spectroscopy. This scientific technique, which breaks down light to reveal chemical compositions, shows metallic cores and unnatural glints from 3I-ATLAS as it speeds through Mars' orbit. These aren't the expected signatures of ice and dust. These are hints of something far more structured, sparking whispers and even outright fears that this isn't just a natural cosmic wanderer. Could it be a probe? A machine under intelligent control? The very thought sends shivers down the spines of seasoned astronomers. The possibility that the unexpected could be an encounter with non-natural technology is the ultimate WTF moment, demanding further scrutiny. A collision of an object this size, estimated to be potentially between 6 and 12 miles in diameter, with Mars would unleash catastrophic energy. We're talking about an impact equivalent to millions of nuclear bombs, a force capable of carving out a crater 60 miles across. The devastation wouldn't stop there. Mars's orbiting fleet of spacecraft, our eyes and ears on the red planet, would be obliterated. And here's the kicker, the thing nobody tells you outright: the debris from such an impact could eventually reach Earth. While the chance might be slim, the sheer scale of the potential fallout is enough to make every space agency on Earth scramble. NASA, ESA, and other global space organizations are working tirelessly behind the scenes, desperate to understand the object and its intentions. But the clock is ticking. September 2025 is the critical window, and every pulse from 3I-ATLAS may be adjusting its course closer to an unimaginable impact. The question isn't if something is about to happen, but what it is and what comes next. Its past journey from beyond our cosmic neighborhood only deepens the real mystery. Decoding the deep space wanderer. This isn't the first time humanity has gazed upon a visitor from beyond our solar system, but 3I-ATLAS brings with it a unique set of puzzles. It's only the third such interstellar object ever officially confirmed, following Oumuamua in 2017 and Borisov in 2019. These objects are astronomical gold mines, carrying clues about the formation of worlds far removed from our own sun. But 3I-ATLAS distinguishes itself with peculiar traits that push the boundaries of known cometary behavior. One of the most striking wow factors is its composition. Unlike typical comets in our solar system, which are mostly water ice, 3I-ATLAS exhibits an astonishingly high ratio of carbon dioxide. The James Webb Space Telescope, with its incredible infrared vision, confirmed that its hazy envelope, or coma, is dominated by this dry ice. To put it mildly, this 8-to-1 ratio of carbon dioxide to water ice is one of the highest ever recorded for any comet. This tells scientists something profound. The conditions in its home star system, billions of miles away, must have been dramatically different from our own. It suggests it might have formed closer to what scientists call the carbon dioxide ice line around its parent star. Another baffling observation is its unusual forward glow. Instead of the expected trailing tail that defines a comet, images from the Hubble Space Telescope revealed diffuse emission ahead of its motion. Imagine a car driving down the road with its headlights on, but the light is coming from behind the car. That's what this glow is like. While some theories suggest it might be due to a lack of rapid spin, preventing ice on its night side from sublimating, the most shocking fact is that this behavior simply doesn't align with the physics of a typical comet. It's almost as if it's pushing ahead of its own exhaust. And you can see this everywhere in the new analyses. Scientists are scratching their heads because the expected dust and gas patterns aren't quite right. The debate around 3I-ATLAS also echoes the controversy that surrounded Oumuamua, the first interstellar object. When Oumuamua passed through, its unexpected acceleration led some, notably Harvard's Avi Loeb, to speculate about an artificial origin. For 3I-ATLAS, the strange pulsing of its tail and the metallic signatures add fuel to that fire. While many conventional astronomers are quick to dismiss these as natural phenomena, emphasizing the sheer improbability of encountering extraterrestrial technology, the persistent anomalies keep the discussion alive. This object, which is very likely billions of years old, represents a unique opportunity to study primordial material from another star system. Its incredible speed is a testament to its long journey through interstellar space, gaining momentum from gravitational slingshots around countless stars. It's a true relic, a time capsule from another cosmic neighborhood. The scientific community is collectively holding its breath, pointing every available telescope and sensor at this enigma. They know that what they learned from 3I-ATLAS could profoundly alter our understanding of planetary formation and the prevalence of life, or at least complex chemistry in the universe. But the biggest question remains: what if its features are signs of something else entirely? The Great Debate. The scientific community, a bastion of logic and evidence, often finds itself at odds when confronted with the truly anomalous. 3I-ATLAS is precisely one of those anomalies, generating whispers and outright contentious debate about its true nature. While many people are crazy about the idea of alien life, the thing nobody tells you is that serious scientists rarely entertain such notions publicly without compelling, baffling evidence. Yet, with 3I-ATLAS, the evidence is mounting in perplexing ways. The most prominent voice in this intriguing debate is Professor Avi Loeb, a renowned astrophysicist from Harvard University. His controversial hypothesis, widely discussed, is that 3I-ATLAS might not be a natural comet at all, but rather a piece of advanced technological equipment, perhaps an extraterrestrial probe. This idea, to put it mildly, has shaken the foundations of conventional astronomy. His arguments aren't based on vague hunches, but on the precise, baffling behaviors observed. The consistent 17-minute pulse from its tail, which appears to steer the object, is a major point. He argues that this rhythmic emission of gas is far too regular to be a random cometary outburst. It suggests a controlled propulsion system. And you can see this everywhere if you look at the raw data. The sheer consistency is unlike anything natural previously observed. What many overlooked is the polarimetry of 3I-ATLAS. This is the study of how light is polarized after reflecting off the object's surface. The way 3I-ATLAS reflects light doesn't match any known comet, either from our solar system or other interstellar visitors. This anomaly, Loeb argues, is a powerful indicator that the object's surface, or perhaps its entire structure, is fundamentally different. Imagine shining a flashlight on a rock, then shining it on a piece of polished metal. The way the light bounces back is distinct. 3I-ATLAS is reflecting light in a way that's simply unprecedented for a natural cosmic body, adding another layer to its mystery. Furthermore, its trajectory and speed add to the intrigue. While it follows a hyperbolic path, its orbit is almost perfectly aligned with the ecliptic plane, the flat disk where all our planets orbit the Sun. But here's the unsettling part. It's moving in a retrograde motion, opposite to the direction of our planets. Loeb suggests this low-inclination retrograde orbit offers distinct advantages for an extraterrestrial intelligence. It allows for detailed observation of our solar system from a unique vantage point. The most shocking fact is that such a combination of characteristics, precise alignment with retrograde motion, is statistically improbable for a randomly passing natural object. The scientific consensus, however, leans heavily towards natural explanations. Critics quickly dismiss Loeb's ideas as nonsense, stressing the importance of exhausting all natural explanations before jumping to extraordinary conclusions. They point to the fact that comets, especially interstellar ones, can exhibit unpredictable behaviors due to their volatile composition. The duck test is often cited. If it looks like a comet and outgasses like a comet, it probably is a comet. Yet with 3I-ATLAS, the duck seems to be quacking in a very unusual way, challenging this conventional wisdom. But a new event has made this debate even more intense. A second player enters. Just as scientists grapple with the enigma of 3I-ATLAS's behavior, the universe has thrown another curveball, raising the stakes in this cosmic chess match. NASA has detected something even more astonishing. A second massive unidentified object, estimated to be 100 times larger than 3I-ATLAS, has just entered our solar system. This staggering size, a true wow factor, dwarfs almost anything we've encountered. Many people are crazy about how we could have missed such a giant, but the thing nobody tells you is that detecting objects far in the reaches of space is like finding a needle in an entire galaxy-sized haystack. The most disturbing revelation about this colossal newcomer is that new data suggests it is heading straight toward 3I-ATLAS. This isn't a random coincidence. This appears to be a deliberate course correction, raising questions no one is prepared to answer. Is it a rogue planet? An interstellar craft of immense scale? Or something entirely beyond human comprehension, an object that defies all categories? The alarming silence from NASA and other space agencies is, to put it mildly, deafening. It's as if they are withholding crucial details, perhaps because they don't yet understand the implications themselves. Leaked observations from powerful telescopes tell a story of strange behavior from this second object. Its brightness fluctuates dramatically, suggesting not just rotation, but perhaps active energy emissions. Its trajectory, like that of 3I-ATLAS, is unexplainable by standard gravitational models alone. It's almost as if the two objects, separated by vast cosmic distances, are somehow linked, moving in concert or perhaps in opposition. The most shocking fact is that if this larger object is indeed targeting 3I-ATLAS, it transforms our single mystery into a complex cosmic interaction, hinting at dynamics we can barely begin to fathom. This is not just a passing object. This could be a major interstellar event. The implications of this tandem appearance are profound. If 3I-ATLAS is, as some theorize, a probe, then what is this second, far larger object? Is it a mothership, a repair vessel, or perhaps a protector responding to the scrutiny 3I-ATLAS has garnered? The very thought pushes the boundaries of our imagination, moving from scientific curiosity to the realm of true science fiction. What many overlooked is that our solar system, long considered a relatively quiet corner of the Milky Way, might be a bustling highway for interstellar traffic, and we are only just beginning to grasp its scope. As these two colossal interstellar mysteries converge, the implications for humanity's cosmic outlook grow larger than ever. As 3I-ATLAS and its colossal companion continue their journey, The universe feels both vaster and more intimately connected to events beyond our star. The unexpected has indeed happened, not as a single event, but as a series of unfolding mysteries that challenge our most fundamental assumptions about the cosmos. For those watching this, wondering if all this happens overnight, the thing is, these cosmic dramas are often playing out over millions of miles and years. We are only seeing a snapshot. The ongoing observations by powerful instruments like the James Webb Space Telescope and the Hubble Space Telescope are crucial. They are our eyes on these distant travelers, gathering data that piece by tantalizing piece helps us to build a more complete picture. The information they've already provided, from the unusual carbon dioxide-rich composition of 3I-ATLAS to the rhythmic pulsing of its tail, has pushed the boundaries of known cometary science. This influx of new data is a wow factor in itself, showing how quickly our understanding can evolve when confronted with something truly novel. Is the universe merely playing tricks, or are we on the brink of discovering intelligent cosmic neighbors? What do you think? Leave your thoughts below, hit that like button, and subscribe for more amazing cosmic tales.